Hey girls, today, as I said, we're going to be continuing rates of change, chapter 3.3, part 2. So in addition to this video link that I sent, I also put a copy of these blank notes on LMS also under the file section. So I would recommend you kind of filling them out while you're listening to me. So first we're starting with a warm-up that is kind of a review of everything we've done so far and that we will continue to use. So what I'd like you to do right now is pull out the blank notes and go ahead and pause this video and complete the warm-up review. So there is 1, 2, 3, 4 questions that kind of review everything we've done so far. So pause this and fill all those out, and then we're going to talk about them. Okay, so first of all, find the limit. So graphical limits. Find the limit of f of x as x approaches 3. So looking at this graph, as x approaches 3, we see we're looking at the function value, right? So coming from the left, the function value is approaching 4, and from the right, it's approaching 4. Or I'm sorry, approaching 5 from the left and the right. So the limit is 5. If we look at the limit of f of x as x approaches 0, so now we're concentrating at 0, but we're looking at the function. And from the left and the right, it's approaching 4. So then it says any PODs, or any points of discontinuity for f of x and y. So if we look at this, the point of discontinuity would be here at 3, because although the limit is 5, the value of f of 3 is -2. So again, remember that the function value is basically the filled in piece of the function at that x. So why is there a POD? It's because the limit of f of x, or the limit as x approaches 3, does not equal f of 3, right? Because the limit is 5, but the function is -2. Okay? So now we go down here, find the limit of the given function algebraically. So again, the first thing you do when you're trying to find algebraic limits is first try to fill in the value. So we get 3 squared is 9 minus 9 over 9 minus 9. So we get 0, 0. So that's an indeterminate form. So we have to continue on and factor. So if we factor the top, we get x times x minus 3. Factor the bottom, x minus 3, x plus 3. Cancel our factors, and now we've simplified it to x, x plus 3. And if we apply the limit as x approaches 3, so we fill in 3, we get 3 over 3 plus 3, 3 over 6, or 1/2. Okay? Next, we find the average rate of change for the following function on the given interval. So again, this relates to last night's homework. So we want the average rate of change. So average rate of change is the f of b minus f of a over b minus a. So for this function, our a is 1, our b is 3. So f of b is going to be f of 3, which is 3 squared plus 2 times 3, which gives us 9 plus 6, gives us 15. F of a is f of 1, which gives us 1 squared plus 2 times 1, which gives us 1 plus 2 equals 3. So now we fill out our formula, and we've got f of b minus f of a over b minus a. 15 minus 3 is 12 over 2, so we get 6. So the average rate of change of this function over the interval 1 to 3 is 6. Okay, so now next one we want to find the instantaneous rate of change for the following function at a given value. So again, this one, now we're using the instantaneous rate of change formula, which is the limit of f of x plus h minus f of x, right, over h. The limit as h approaches 0. So given this function at x of 2, so we're going to be finding the limit as h approaches 0 as of f of 2 plus h minus f of 2 all over h. So as we fill that in, f of 2 plus h is going to be negative 4, 2 plus h squared minus 6, right? All of that is just f of 2 plus h. And then minus f of x, which is, f of 2, so negative 4 times 2 squared minus 6, and then all over h. So as we simplify this, first of all, I'm just going to simplify f of 2. So that's going to be 2 squared is 4, times negative 4 is negative 16, minus 6 is negative 22. 4 times 4 is 16, negative 16, yeah. And then, so now we're going to simplify the f of 2 plus h. So first we have to FOIL, so we're going to keep that negative 4 hanging out there. When we FOIL this, we get 4 plus 4h plus h squared minus 6. Now we distribute our negative 4. We get negative 16 minus 16h minus 4h squared minus 6. And then bring down our minus negative 22, which makes it a plus 1, negative 22. All over h. So now, as we said in class, hopefully if we did our math right here, the constants cancel out, and we get negative 16 minus 6 plus 22. All of that adds to 0. So this, and that all add to 0. So now negative 6h, or negative 16h, minus 4h squared all over h. And we're taking the limit as h approaches 0. So to simplify that, we can take out an h, and we get negative 16 minus 4h all over h. Well, shoot. And now, sorry about that, girls. So now the h's cancel. So the limit as h approaches 0 of this equation is negative 16 minus 4 times 0. So we get negative 16. So hopefully it's a little review for you of everything we did last class, and actually pretty much everything we've done all chapter. So now we're going to continue on with rates of change, but apply them instead of to just equations or velocity, we're going to apply them to business equations. So take a look at our notes. Now, we're still talking about instantaneous rate of change for x equals a number. So we're still using the same definition of that, which is the limit as h approaches 0 of x plus h minus f of x. And if you follow your notes here, it says instantaneous rate of change, again, is how fast one variable is changing with respect to another one at a specific value. So that's what makes it instantaneous rate of change, different than average rate of change. And so the terminology we use for this method depends on the type of equation we're talking about. So last time we applied it to a position function, like an object moving, or if we talked about a car driving, or a ball bouncing, being thrown, etc. Those are all position functions. So the instantaneous rate of change refers to velocity when you apply that limit. What we're looking at today are business functions. So when we do the same definition of this limit as h approaches 0, when we apply that, instead of calling it velocity, we're going to call it marginal cost when we apply it to a c of x function, marginal revenue when we apply it to a revenue function, or r of x, and marginal profit when we apply it to a profit function. So part of mastering this is learning the correct vocabulary. So just know when we talk about velocity, then we have applied the instantaneous rate of change equation to a position function. When we talk about marginal cost, revenue, or profit, we have applied the instantaneous rate of change to a business function. Okay, so let's try some. So here we have a company determines the cost in dollars to manufacture X cases of DVDs is this. So here's our cost function. And here where it says from 0 to 7, that just means that this equation only applies for the domain of 0 to 7, which we don't have to worry about that right now. We are not going to be using any other numbers except between 0 and 7. So this is find the average rate of change of cost per case for manufacturing between 1 and 5 cases. So here it's telling us average rate of change. So we're going to use the old formula for manufacturing between 1 and 5 cases. So that tells us we're going to use the average rate of change formula right now, which is this, if you recall from last class, and we're going to let A equals 1 and B equals 5. So if we, apply this, and actually here we're going to just use accurate business terms. So really, looking at this equation, we're going to say C of B minus C of A over B minus A. And again, I just changed it to reflect what we're calling our equations. So C of 5 equals 100 plus 15 times 5 minus 5 squared. And if you plug that in your calculators, you get 150. And C of 1 equals 100 plus 15 times 1 minus 1 squared, which gives you 114. So now if we apply our formula for average rate of change, we get 150 minus 114 divided by 5 minus 1, which gives us 36 over 4, which gives us 9. So the average rate of change in cost between 1 and 5 cases is 9. So we're saying the average change between 1 and 5 cases is $9 per case. Okay, so on average, that's how the cost is changing. Now, next problem's a little bit different. It asks us for the instantaneous rate of change when 2 cases are produced. So now we are taking it, we want to find out not the average rate of change over an interval, but the instantaneous rate of change when x equals 2. So now we're going to apply our limit formula. So we want to say, what's the limit as h approaches 0 of c, again, because that's the name of our formula, c of 2 plus h minus c of 2 over h. And again, don't let the change between calling a function c and calling a function f throw you, but it's just using the proper terminology. So now when we want to write c of 2 plus h, it's going to be 100 plus 15 times 2 plus h, because again, we're just inserting 2 plus h everywhere we see an x, minus 2 plus h squared, and then minus, let's change colors here, c of 2, which would be 100 plus 15 times 2 minus 2 squared. So if we continue to simplify that, let's first look at just c of 2. So we have 100 plus 30 minus 4. So this becomes 126. So hopefully all of you guys agree with that. Now if we simplify this equation, we get 100 plus distributing the 15, 30 plus 15h, and then minus 2 plus h squared. So we have to FOIL that, and then we're going to subtract it. So we get 4 plus 4h plus h squared. So if we continue simplifying that, we get 100 plus 30 plus 15h minus 4 minus 4h minus h squared minus 126. So again, really important to remember to distribute that negative. So if I continue simplifying now and give myself a little bit more room. So now if we combine like terms, we get 100 plus 30 is 130, minus 4 is 126. So if you all will stay with me here, all of this cancels out to 0, right? Because we have 126 minus 126. So now we are left with the limit as h approaches 0 of 15h minus 4h is 11h minus h squared over h. Simplify by factoring out an h, and we get this, h times 11 minus h over h. H is cancel. We get 11 minus h, which is 11 minus 0, so we get 11, which represents a cost of $11. So what this is saying is the average rate of change in the cost from 1 to 5 cases was $9 a case, but when we actually produced that second case, the cost was $11. So again, it averaged out amongst 4 cases to $9 a case, but the second case itself was $11. Now it asks us to do the same thing, instantaneous rate of change, when 5 cases are produced. Okay, so again, we do the same formula for x equals 5. So we're going to say the limit as h approaches 0 of c of 5 plus h minus c of 5 all over h. So c of 5 plus h is going to be 100 plus 15 times 5, times 15, 5 plus h minus 5 plus h squared, and then minus c of 5, which I'm going to cheat just a little bit here because we already found c of 5 up at the beginning, and c of 5 is 150. So I'm going to, and it's still 150, so I'm going to go ahead and just kind of use what we did earlier and as part of our formula, as c of 5 is 150. Okay, so now we're going to simplify c of 5 plus h, so we get 100 plus 15 times 5 is 75 plus 15h, so again I'm just distributing the 15, minus FOILing 5 plus h, we get 25 plus 10h plus h squared, and then bringing down our 150. So now we simplify further. 100 plus 75 plus 15h, distributing that negative, negative 25 minus 10h minus h squared, and bringing down our negative 150. So now let's hopefully our constants cancel out. So 100 plus 75 is 175, minus 25 is 150, minus 150. So yay, that all cancels. So now we take the limit as h approaches 0 of 15h minus 10h gives us 5h minus h squared over h. We factor out an h, and the h is canceled, and we get 5 minus h, which is 5 minus 0. So the instantaneous rate of change when 5 cases are produced is $5. So let's talk about that for a second. So the instantaneous rate of change at 5 cases is $5. At 2 cases, it's $11. And when you think about cost, again, as items are produced, the cost should go down the more items that are produced, right? So the cost of producing one item should be a greater per item cost than when you're producing like 5 items. I hope that makes sense. So it does make sense that the second item cost $11 to produce, but the fifth case costs $5 to produce. And again, that all kind of supports that the average cost between 1 and 5 cases is 9, and that is right there in the middle. Okay, so hopefully that's starting to make a little bit of sense to you guys. If we'll talk about this more next class, obviously. But that is looking at instantaneous rate of change using a cost function. Now we're going to look at it using a profit function. So last chapter we had to come up with cost, taking revenue minus cost gave us profit. Now they're giving us the profit function, so they've kind of taken a step out away from us, which is good. We've got this profit function. So we want to find the average rate of change in profit from selling 6 to 9 pounds. So it's average rate of change. So first we're going to use the P of B minus P of A over B minus A. And we're going to let 6 be A and 9 be B, using our profit function. So P of B is P of 9, and that's 15 times 9 plus 25 times 9 squared, which equals 2160. Okay, P of A, which will be P of 6, will be 15 times 6 plus 25 times 6 squared, which will be 990. So if we fill in our formula, 2160 minus 990 over 9 minus 6 equals 1170 over 3, which equals 390. So the average rate of change of profit between selling 6 to 9 pounds of potatoes is $390. Okay? So that's how much on average the profit changes. Now we want to find the marginal profit from selling each individual amount. So exactly how much is the profit changing when we sell exactly 6 pounds, and how much is it changing when we sell exactly 9 pounds. So now, hopefully y'all are getting the hang of this, now we're going to use the limit formula. So the limit as h approaches 0 of P of, for this one we're going to do 6 plus h minus P of 6 all over h. So P of 6 plus h is going to be, hang on a second, let me look at my formula again. It's going to be 15 times 6 plus h plus 25 times 6 plus h squared minus P of 6. And actually we know we have P of 6 up here because we just found it. P of 6 is 990. So I'm going to go ahead and, again, do a little shortcut, bring that out. So now as we simplify this, 15 times 6 is 90 plus 15h plus 25 times 6 is 150. No, I'm sorry, plus 25. Almost made a huge mistake there. Times foiling. So now we're going to foil 6 plus h. We get 36 plus 12h plus h squared minus 990. Simplify 90 plus 15h plus 25 times 36 is 900 plus 25 times 12. This is where I really hope this is going to work out. 300h plus 25h squared minus 990. So if we did all this math right, which I'm hoping we did, then our constants cancel out. So we have 90 plus 900 is 990 minus 990. So yes, doing all that like I did on video worked. So our constants cancel out. So now we're taking the limit as h approaches 0 of 15h plus 300h, which actually is going to be 315h. Go ahead and combine those. Plus 25h squared all over h. Simplify it by taking out h. The h's cancel, so the limit as h approaches 0 of 315 plus 25 times 0 is 315. So the instantaneous rate of change for profit at this selling 6 pounds of potatoes is 315. Now we want to try the instantaneous rate of change. Oh, I thought that was separate. Of 9 potatoes, 9 pounds of potatoes. So let's run through that. So we have the limit as h approaches 0 of p of 9 plus h minus p of 9 all over h. So we get 15 9 plus h plus 25 9 plus h squared minus, and again, we know p of 9 from above is 2160. Move that all down a little bit. Okay, so now we simplify this. We get 15 times 9 is 135 plus 15h plus 25. Foiling, we get 81 plus 18h plus h squared minus 2160. So we get 135 plus 15h plus 25 times 81 is 2025 plus 25 times 18 is 450h plus 25h squared minus 2160. So now again, make sure we did all that math right. We try to combine, hopefully all of our constants cancel out. So 135 plus 2025, yes, equals 2160. So they do cancel. And now we take the limit as h approaches 0 of 15h plus 450h gives us 455h. I'm sorry, 465h. I'm kind of winging this like I do in class, so catch me or let me know later if my math is wrong. 450 plus 15 is 465h plus 25h squared all over h. We can factor out an h, so 465 plus 25h all over h. So when we apply our limit as h approaches 0, we get 465 plus 25 times 0, so we get $465. So the instantaneous rate of change of profit on that 9 pounds of potatoes was $465, and the change in profit on the 6 pounds of potatoes was $315. So again, and this again makes sense because we're talking profit. So you do expect your profit to rise is you're selling more potatoes, right? Where we expected cost to go down as we were making more products, we expect profit to rise in some functions. So, and in this one, it makes sense. So 9 pounds, the rate of change was 465. 6 pounds was 315. And the average was 390. And so that makes sense also, because that's kind of right in between the two of them. Okay? So hopefully you guys are getting used to the mechanics of taking the instantaneous rate of change or average rate of change. So what I want you to do now is, when you turn off the video, go ahead and your homework is actually on this also. So number 12, number 18, 29 A through D, 31 A through C, 32 A and B on page 189. So finish that up and we will check all the homework from page 189 on Monday or Tuesday, whenever I see you guys next. So have a great weekend and I will see you next week.